Good morning or good afternoon to the 366 students whenever you are deciding to tune in and watch this particular video lecture. Today will be a quick lecture as we are just going over a FITS example and a continuing on of what we started on Wednesday where we did a introduction to tolerances and FITS in general. So again, today we're just going to be going over a FITS example. This will be no homework will be on this particular video lecture. However, there will be a section of this on the project 3 and also on the final exam as well. So I encourage you to follow along at home or from wherever you are watching this this video. Okay, so today we are going to be going over a ISO example where we need to find a loose running fit for a 2 1/4 inch shaft and hole as shown down below in our small diagram shown on the slide. You'll be notice that I'm working from a Word document. I'll be posting the actual slides for this lecture up to Canvas. However, for the sake of being able to work through the problems as they go along, I will be working from a Word document this time around. Okay, so here is our description of our clearance fit. So we are specified of a loose running fit. This is fit for wide commercial tolerances. We also have free running, close running, sliding, and locational clearances, all of them for this ISO clearance fits. However, given this problem, we have a loose running fit that is highlighted here in red. So to continue on, here we have our ANSI and ISO fits table. So we have a ANSI shown over here on the left, and then we have our ISO shown over here on the right. Always make sure that you're picking the correct standardization unit. I think every single semester I've seen someone go ahead and pick the wrong ANSI or ISO standardization, and they work everything correctly. However, they picked the wrong call out number, and all the numbers were off just based off of picking ANSI versus ISO or ISO versus ANSI. So always make sure you have the correct standardization unit, and that will make for your calculations to be correct. So in this case, we have an ISO, and then we have a loose running, and H11C11 is our call out that is highlighted over here in red. Continuing on, here we just have our example problem once more. So we have a 2 1/4 inch shaft and hole that we need a loose running fit. So a loose running fit call out is our H11C11, and that is boxed in over here. And then we have our basic diameter specified right over here by this particular box, 2 1/4 inches. That is our basic. So just one more time, looking at that chart again, here we have our loose running and then our call out H11C11. You'll notice that each one of these has a different capital or lowercase letter. The capital letter will always correspond to our hole diameter. So that's why I have that bolded. That is a capital H, and that corresponds to our hole diameter, and capital letter from our call out. And then we have a lowercase letter that is our shaft diameter. I'll go ahead and underline that. So we have a shaft diameter that is our lowercase letter, and that is given over here in the lowercase letter as well. So these problems are not particularly difficult based off of math. The math is all very easy. However, you do need to pay attention to where you're putting which numbers. And that's really the trick to these types of problems is just making sure that you have put the numbers that are correct in the correct spots. Okay, so then we're ready to take a look at our tolerance charts and start actually assigning numerical values to those symbols that I just went over. Okay, so we will start with our upper deviation letters. So we come down here to our basic sizes. This is our basic dimension that was provided in the problems. That is 2 1/4 inches. So that falls right in between 2 and 2.6. So I'll go ahead and underline that. Upper deviation, there we go. And then we'll go ahead and make that a little bit wider so that we can see it. There we go. And then, so that will make sure I'm always picking the correct numbers from the right row of our chart. And then we'll do the same thing for our tolerance grade. So again, that 2 1/4 inches is our basic size. So we'll come on up here and just make it underline it so that I could see where I'm working from, and then make it a little bit wider. There we go. So we have our basic sizes. Our 2 1/4 inch basic size row is underlined. So then we are ready. And then always make sure that I can grab the right number from this chart. So our basic size, that was 2.25 inches. And then our loose running fit, that was our loose running, and that corresponds to our H11, capital H11 to C11 lowercase. Okay, so now we are ready to start actually assigning numerical values from that chart. So H, and then we'll do 11. So our H, that corresponds to our whole tolerance, and that is provided up here. So our upper deviation letter, you'll see that these are all lowercase letters, but from our call out chart, we have an uppercase letter. So that will be indicate that this corresponds to our whole diameter. And that is equal to, I'll go ahead and just grab a box and go ahead and highlight that H so that I can remember and highlight where I'm getting that number from. So I'll make that highlighted in red. And of course, no fill so I can read it. That H, that corresponds to 0 inches. And then our 11, that goes up to our tolerance grade where we have H11. There we go. And then we'll go ahead and outline that in red as well. Okay, so then we have our 0.0075, and that goes with our 11. And then we'll start working on our lowercase letter. That would be C. We'll go ahead and grab another box to show you where I'm getting these numbers from. That is C with our correct basic size, so that is 0.0055. Go ahead and highlight that in green, and then we'll make that no fill so we can actually see it. So that corresponds to a negative 0.0055 inches. Then we have our 11, that's C11 again. That is the same number as before. From our tolerance grades, that IT11 basic size shown over here in our row, and we'll go ahead and highlight that again as well, except this time we'll make it green just to be consistent, and that is 0.0075 inches. Okay, so now we have our basic size, our fit, our call out, and then our call out all defined with numerical values. Now we're ready to start doing some actual tolerance calculations. So we'll start off with the whole, and then I'll go ahead and make that bold and underline, showing that if we're giving this a capital letter, that corresponds to our capital letter from our call out, bold and underlined as well. Okay, so then our D minimum, this is going to be our minimum diameter that is allowable in the hole. So this would be our basic plus letter. So this would be our 2.25 plus our uppercase H, which equals to 2.25 plus 0 inches. And the minimum then is equal to 2.25 inches. So this is our minimum diameter that is allowable for our hole. So our change in diameter, this is the change in the hole diameter. This corresponds to our IT numbers. This is IT number, which in this particular case was IT11. So our D max now, we have to do our calculation, which is going to be our D minimum plus our IT number, which is number 11 in this particular case. Go ahead and make that smaller. D minimum and then IT11. This course, so our D minimum that was calculated before. So we'll go ahead and write this up there. So our D minimum that was from right up here. Go ahead and give you an arrow to show you where I'm getting that number from. In this particular case, the D minimum is equal to our basic dimension. However, that will not always be the case. So it's very so you always have to calculate the D minimum before moving on to the diameter, the maximum diameter. And there, our calculation is going to be D minimum, which is 2.25, plus our IT number, which is 0.0075 inches. Okay, and then we'll just run through some quick math, and we can see that our maximum allowable diameter is 2.2575 inches. And now we are ready to assign these correct dimensions. And as we can see, we're given these in bilateral, which is basic plus or minus the tolerances. So our basic, which is 2.25, and that will be equal to our upper limit, which is, there we go, which is going to be plus 0.0075 inches, and then our lower limit from our basic diameter, which is actually just plus or minus 0. So there is our, I'll go ahead and grab a box to just box that in, where we have our upper and lower limits on our on our hole diameter given by our capital D shown here, that's 2.25 plus 0.0075 inches. Okay, so now we're ready to move on and calculate the shaft diameter tolerances. And we have the same, again, we have that lowercase letter this time, and that corresponds to our shaft diameter, and that was taken from right up here as well. So we'll go ahead and give that a quick underline, but no bold, to show that it is a undercase letter. So our letter in this case was equal to a negative 0.005. That is our C, so 0.005, here we go, and that is equal to lowercase c. In this case, it is our still the same formula, our basic plus our letter. However, we have a negative number where we have to actually subtract from our basic diameter. So it's going to be 2.25 plus a negative 0.0055. That will give us our maximum diameter of our shaft that is allowable for this particular problem, which is going to be 2.24545 inches. So that is our maximum diameter of the shaft that is allowable for this loose running fit. Our change in diameter, our change in shaft diameter, that is again our tolerance number, which is IT number. And for this particular problem, it is IT11. So we come down here, and then we have our formula for this. That is our D maximum minus our IT number. And then same concept as before, where we have to calculate the D maximum before calculating the D minimum. So this D maximum, that comes from this number that we calculated before minus our IT number. And then our IT number was 0.0075 inches. Okay, so our D minimum is going to be 2.2445 minus 0.0075 inches. And that gives us a minimum diameter of our shaft or our pin to be equal to 2.2370 inches. So again, that is our minimum diameter of our pin that is allowable for this particular case. So now we can move on to writing out our basic tolerances. So that would be our lowercase d, that corresponds to our shaft, and that would be our basic, so 2.25. And then from doing these tolerances, we always work off of the basic dimension. So in this case, we have to take the difference between our D maximum and our basic tolerance. So that would be in this, so minus 0.0055. That is the difference between our basic tolerance and our D maximum. And the same thing for our smallest dimension of our pin. We're working off of that is the difference between our D minimum and our basic dimensions. That would be negative 0.0130. So that corresponds to the difference between 2.25 and then our D minimum value that we calculated up here in this line right here. Okay, so that is our two tolerances. There we have our, I'll go ahead and draw a box around those as well. And then we have our D minimum and D maximum for our hull and our shaft, and then the corresponding tolerances as well. So now we are ready to move on to calculate our allowance and clearances. Just as a quick review, so I'll be using MMC, so that is the maximum material condition, and that is either the smallest hole or the largest pin, depending on which parts you are looking at, or the least material condition, that is the largest hole or the smallest pin. So we will start off by calculating the allowance. That is the intentional difference between the maximum material limits of mating parts, and that can be positive or negative. So the allowance is equal to the maximum material condition of the hole minus the maximum material condition of the pin, or the smallest hole minus the largest pin. So the smallest hole in this problem was our D, our capital D. That would be our largest diameter of the holes, or D minimum, minus the diameter maximum. So I'll quickly make those smaller there. right there. And then when we come on up here, we'll see that our D minimum, I'll go ahead and highlight these in yellow. So our D minimum given right here, and then our D maximum, which was given, which we calculated right here. So I'll highlight those in yellow, and then come on down here, and then we'll just write them out and solve for our allowance. 2.25 minus 2.2445, and that gives us our allowance, which is 0.0055 inches. Okay, and I'll go ahead and underline that as well. So that is our allowance, and now we're ready to calculate the clearance. The clearance is the loosest fit or maximum intended difference between mating parts, or that is the largest material or the least material condition of the hole minus the least material condition of the pin, or the least or the largest hole minus the smallest pin. So in just to assign variables to this, this would be our maximum diameter of the hole given by that capital letter minus the minimum material condition or the smallest pin. That is our smallest diameter of our pin given by that lowercase letter. So D min minus D, or D max minus D min. And I'll go ahead and highlight these in green. So our D maximum up here, that was 2.275 highlighted in green. And then minus our D minimum, which is going to be highlighted in green as well, which is 2.2370. So I'll exit out of there, and then write in our values of 2.275, 2.2575 minus 2.2370, which gives us a clearance of 0.0205 inches. We will go ahead and put that in underline. Okay, so we have calculated our we found our tolerances, calculated the maximum minimum diameters for a loose running fit between a shaft and a hole of basic size 2.25. So we went up here to our charts, found the proper numbers that correspond to our callouts, ran through our calculations to find our Dmin and Dmax for the hole and the shaft, and then we wrote up our tolerances, and then came through here and calculated our allowance and clearances. Okay, that will do it for this video lecture. Again, we have no homework for right now. However, your homework is to work on Project 3. And just keep in mind that this is a large part of Project 3 and also the exam. So I would encourage you to work through the quiz and really understand what you're doing. And if you have any questions, please feel free to ask either Dr. Duty or myself. All right, thank you very much.